Have you ever wondered what it takes to build a railway where trains rocket along at over 200 miles per hour? It's not just about laying down some steel on gravel. It's a story of incredible precision, massive machinery, and engineering genius. This isn't ordinary track laying. It's a monumental battle against physics, terrain, and time itself. The engineers use advanced GPS and laser surveying tools to map out a route that's as straight and level as possible. Sometimes, moving millions of cubic feet of Earth to make it happen. That means reshaping the planet itself. Every tiny deviation is magnified at high speeds, so precision here is everything. Next, we have the foundation of the track itself. This is where high-speed rail becomes unforgiving. The foundation must be rock solid. Traditionally, railways use ballast, that familiar word. For over a century, ballast has been the heartbeat of conventional rail. But at super high speeds, ballastless track, the price of breaking the sound barrier on rails. That's why many modern high-speed lines use something called a slab track, a rigid, inconsistent part. Instead of loose stones, the rails are fixed directly onto a solid concrete slab, which is crucial when trains reach super high speeds. Every imperfection becomes catastrophic. But for super high-speed rail, it's the smartest investment in speed and the future of transportation. But the long-term reliability is worth every penny. Yes, slab track costs more to build, but that premium buys. But what about the noise and shaking? Modern slab track systems are engineered to prevent that, achieving quieter, smoother rides. A train weighing hundreds of tons, traveling faster than a race car, creates immense vibrations that can travel through the ground and affect nearby buildings. Engineers use sophisticated vibration control systems to stop ground-borne vibrations. Giant specialized spring systems that act like a massive shock absorber for the railway. These are not ordinary springs.
It's absorbing the energy and ensuring a smooth, quiet ride for passengers and peace for the surrounding community. From meticulously planned alignments to solid foundations and advanced vibration damping, building a high-speed railway is a monumental feat of engineering.
This is not laying track, this is rewriting the landscape, conquering physics, and bending time itself. It's a system where every single component works in perfect harmony to deliver speed, safety, and comfort. The next time you see a high-speed train fly by, you'll know you see the incredible science hidden just beneath the rails. And if you enjoyed this look into modern engineering, systems of the Hengship Sponder machine, we dive